In class, this is Mr. Walker coming to you with our final parts for angles that are inside of circles. So, we are talking about a new line and a new kind of angle that's going to be formed from this line. So, let's introduce our friend the secant. A secant is a line that intersects a circle in exactly 2 points. So, when we look at a secant, that is a line that comes from one end of the circle through another end of the circle to a point that is outside of the circle. So this right here is a secant. It's kind of like if you took a chord and you continued it on outside of the circle. Now, sometimes we have angles that are formed by two of these secants. When we do, we get this measurement by taking 1/2 the difference of those intercepted arcs. So, 1/2 the difference of our two arcs. Now, let's first talk about the word difference. Remember, we've seen this in the past. It's just important for us to know. This is when we have things that subtract to give us an answer. So when we are taking the difference, we are subtracting two things. Now, when we are taking this difference, it's important for us to look at our angle, RST, which is this one right here, and we are subtracting two arcs. This arc outside from this arc inside. So when we look at this, it's important for us to know the two things we are taking. We are taking our big arc and subtracting it from our small. So big arc minus a small arc, and then we take 1/2 of this. That's going to be what gives us our answer. So in our example here, we have two arcs. We have our big arc here, 115, and our small arc here, 41. And we want to find the angle out here, LKJ. So what I do is I take the difference of my two arcs. So 115 minus 41. And then I divide them by 2. Now 115 subtracted from 1, not 1, 41. So let's see, that's going to give us, that's a 4 here. And then that's going to give us a 7. And then when we take 74 and divide it by 2, we get an answer of 37. So we always go through it just like this. Large arc subtracted from the small arc divided by 2. Reason why it's large from the small or big from the small, you have to make sure. You can't get a negative angle measure. That doesn't make sense. It's like having a negative distance. We can't actually go through and measure that because if it was a negative, then it just wouldn't exist. Now, that's not to say we can't get negative answers. You can if you were solving for x. If you're solving for an x, you can always get a negative. You can get a positive. You can get a decimal. But in terms of the arcs you're going to be dealing with, they will be positive numbers if you're just going through and finding out what this angle measure is without any algebra. Next one that we got on deck here are two tangents forming an angle. So the measure of an angle formed by two tangents is 1/2 the difference of those intercepted arc measures. Now, remember what a tangent is. That's a line that hits from the circumference of our circle out to a outer point outside of the circle. So these two lines here are tangents. You might also notice there's something different about our arc here. Our arc has a letter that's in between them. And when we look at this formula here, this arc, this big arc ADC, has 3 letters. So what is this formula really saying that's different from our previous one? We are still subtracting our two arcs, but this first arc is what's called a major arc. And this second one, because it has 2 letters, that is a minor arc. And then we still take 1/2 of whatever that is. Now, Things to remember: a major arc, this is a number that is bigger than 180. So this is greater than 180. I'm adding this context so that you know your major arc will be big. And your minor arc, this is something that is less than 180. So it will be smaller than 180. And we're still subtracting, so that part has not changed for us. So our first example here, we got our major arc, 250, our minor arc, 110. And we're trying to figure out this angle, DEF. So we take 250 and we subtract from it 110 and then divide by 2. So 250 subtracted from 110 gets you 140. 140 divided by 2 gets you 70. So that's all you need to be aware of. It's nothing too deep, it's nothing too crazy. It's the same formula from before, just some extra context that we can't ignore. All right, now for our final one, this is if we have an angle formed by a secant and a tangent. So an angle formed by a secant and a tangent is, once again, 1/2 that difference between our intercepted arc measures. So what is it that we really need to be aware of? Let's focus. In our example here, to find angle JKM, which is this one right outside, I take half the arc's difference. So this first arc, JM, that's this outside one. And this one, JL, that's this inside one right here. So once again, we're doing a subtraction similar to our first formula. We take our big arc and we subtract it from our small arc. And then we take 1/2 of these two. So big minus small, 1/2. Another thing that we need to be aware of, we're not going to worry about this bottom part. This is gobbledygook. It doesn't help us out. We want the intercepted arc measures. So you can check this by looking at the two letters that make the outside portions of your angle and look for any arcs that are in between those two sides. So this arc and this arc, they're in between the two sides. That's why you would use them as opposed to this one down here. Is this touched by our angle? Yeah, but it's not intercepted by it. So let's look at another example. We have two arcs here that we could use to find our angle FHI, which is out here. So when we do this, we take our two arcs, we got 126, and we're subtracting 88. After we get those two, we then divide it by 2. So 126 minus 88, what does that end up giving us? Let's go through and do a little bit of subtraction. 126 divided by, so that gets me 38. And then when I divide this 38 by 2, I end up with a 19 as my final answer. So make sure that you look at your angles, look and see what they're made up of so that you can apply the correct formula and know what parts you need to use for that formula. Let's take a look at a couple of examples, people. All right, each of these, we have either some, detective work that we got to do, or we can just go straight onto our formula. Our first one here, this is on the we do it. So we have this outside angle, 50, and it is being made up of two secants. So that means I am going to be taking the difference of our two secants. So we take our big one, this one right here. This is the outside arc. This is our big arc. This one here, this is our small arc. And this right here, that is our angle. Now that we know, let's set up our formula. We are taking the difference of these two arcs. So 12x plus 8 is being subtracted by 4x plus 4. And it's divided by 2 to give us 50. All right. Now that we're here, it's important to know some structural changes are going to happen. I need to get rid of this 2 that's down here, just like we did in our previous notes. But as well, this negative is affecting this whole parenthesis here. That's why you see the parenthesis still there. So when we do this, we got to distribute this negative in. That turns into minus 4x minus 4 here. So when we get to combining like terms, just remember that negative affects both of these. All right, let's keep going. I got to multiply this 2 to both sides. So that 2 and this 2 cancel out. On the other side, we got 50 times 2, that's 100. And then up top, we're going to have to combine our like terms. So this 12x is getting subtracted by this 4x, and this 8 is being subtracted by that 4. That's going to give us, on the left side, 8x plus 4 is equal to 100. Now that we don't have any fractions going on here, we can just solve this like we've done in the past. I have to get rid of this 4 by subtracting. So that's what gets us 8x is equal to 96. And then I have to get rid of this 8 by dividing, which gives us a final answer of 12. So nothing too crazy. No, we can't go through and handle. We just have to be aware of all the parts that are there. Okay? All right. Just like last time, we do sometimes have some detective work to work out. So let's think about this. These are two tangent lines here. I can tell because they're only hitting in one place each, here and here. Now this right here, this is my angle. And x, even though I don't see a third dot over here indicating a point, I can tell that this is a major arc. I can tell because this looks like it's more than half the size of the circle, which means that this part right here, this is our minor arc. So we're going to take the difference between our major arc and our minor arc. But what is this minor arc? Remember a couple things that we know about circles. Circles total 360 degrees in measure. So if that's the case, our major arc here, I know it's a little more than half the size of the circle, but how do I find this minor arc? I would just take 360 and subtract from it x. So that's what this guy is right here. That's a little detective work we had to do. So once we know that, we can set up our formula. We have x minus 360 minus x divided by 2 is equal to 38. Same deal as last time. We deal with this negative. It's changing both of these signs here. So that is going to be a minus 360 and a plus x. And then we also got to deal with the 2 that is in the denominator by multiplying it to both sides. This side, they're donezo. We don't have to worry about this. This side, we'll multiply 38 times 2. That's going to give us 76 over there. And then when we combine our like terms, those x's give us a 2x. And that minus 360 is still there. All right. Right now we're subtracting by 360. So to do the opposite, we got to add 360. That gives us 436. And then when we divide both sides by that 2, our final answer is 218. So it's fine for you to go through and get wild or big numbers or things that are a little different when we're solving for x. But if we were trying to find our angles specifically, we have to be aware we'll have to plug x back in. This isn't asking us to do that, so just keep your eyes on a swivel for that. Next one we got an angle inside, we got an angle outside. We also got another setup with some tangent making up an angle. So pause this, give it a try, and come back. All right, hopefully you paused it. Welcome back. Let's get into this last part here. We got our I do it, and we got some examples on the bottom. So for our one here, we got our 2 arcs, our inside arc, our outside arc, our big arc, our small arc, and then they make this angle here. So when we set this up, We're subtracting that big one, 14x plus 6, with 58 and dividing it by 2 to get what we have here, 2x plus 14. Now, compared to our previous ones, we haven't had any x's on the other side, so this time we'll have to go through and move our x's later. So let's get our first step done. We multiply both sides by 2. This side is now just a nice, easy equation. And then when we get to here, we can combine our like terms. These two, that's a positive and that's a negative. So that's going to be a negative because that's the larger of the two. And then when I combine them, I get 52. Now over here, this 2 gets distributed inside of this parenthesis here. I have this parenthesis set up because there's not just one thing here that's being multiplied by 2. This time there's 2 things. So when I distribute that in there, I end up getting on the right side 4x plus 28. On the left side, that 14x now has a new person with it, 52. We now need to combine our like terms. I'm taking a look around. Is there any there? Nope. So we got to move our constants to one side, our variables to the other. That 52, I'm going to add over to the other side with that 28. That 4x, I'm going to subtract to the other side with the 14. So 14x minus 4 gets me a 10x. When I add that 52, it's going to be a positive 80. And then when I divide both sides by 10, my x will finally be 8. Now, just like how we did for our second one on the we do it, we got our I do it with some detective work here. So this right here, this is our minor arc. But what is our major arc? To find this major arc, we got to take 360, just like we did before, and we are subtracting our minor arc, 110. So when we subtract those two, I end up with 250. So I got 250 minus 110 divided by 2 gives me 5x plus 10. Now, in the past, we had to go through and multiply both sides by that too, because that fraction had x's in it. But this time, our fractions don't have x's in it. So we can just go through and evaluate this. So 250 minus 110 is going to give you 140. And then 140 divided by 2 gives me a 70. So this one, a little less work for us to have to handle. Then we get to solve it. So that 10 has to come over to the other side by subtraction, so that gives us 60. That 5 has to get divided by both sides, giving us a final answer of 12. All right. We got our challenge section here on the bottom, so we got plenty of things to go through to do. Why don't you take a look and see what you can figure out? Pause it, come back. All right, hopefully you paused it and you want to come back, so let's go through and challenge ourselves this time. Same type of deal. We're subtracting our big arc from our small arc, or our major arc from the minor arc in the case of this one on the bottom. So let's go through and show you the math. Our angle that we're setting this equal to is 5x minus 10. And over here on the right side, we got 13x plus 7 minus that small arc, 60. Remember these two? They're going to get combined. So when we combine those two, that gives me a negative 53. And this 2 is going to have to get multiplied to both sides here. So that's times 2. This side here also being multiplied by 2. But remember, that's just to cancel this out. When we come over here, we'll distribute to this 5x and this minus 10. So here's our new equation. 13x minus 53 is equal to 10x minus 20. I bring all my x's to one side, all my constants to the other side, so I end up with 3x is equal to 33. And then when I divide both sides by 3, I end up getting an 11 for our answer. Nice and easy. We were able to handle it. Next one, this is similar to the one that we did on the I do it. So I have my inside arc, I have my outside arc, my big arc, my small arc. They're going to be subtracted and divided by 2. And then they equal our angle, 3x plus 13. Okay, so once we have these two equal, even though you see that we could calculate this, I'm going to warn you, it gets a little messy sometimes. So what we're going to do, we're going to just try to flex our knowledge just to get used to that process like before. So we're going to be multiplying both sides here by this 2. Now, do we always need to do that? No, but let's go through and venture to that little choice. So multiplying both sides by 2 ends up with me having to distribute this inside of this parenthesis. On the other side, we got us a nice easy subtraction of 92 is equal to, on the other side, 6x plus 26. Now, I have to take that 26 and subtract it from both sides. That's how I get 66. And when I divide both sides by 6, you get 11. So, do you have to go through and divide both sides? No. Do you always have to multiply both sides? No. But it's always good to, get that knowledge out there, that chance to try. All right. Hopefully you could try out this last one. I'll go through, and if you did try this, let's go through and show you our calculations. We got our angle is equal to our two arcs being subtracted. We got to deal with that too, so we always distribute that to the other side, and we'll combine our like terms up top. Once I combine my like terms up top, we're solving for x like we normally did. Subtracting the 10, adding that 10 over there. It's actually, we subtract the 10 twice. I'm subtracting this 10 over here. I'm subtracting this 10x over here. And then when I divide both sides, saved by the bell, folks, you get x equals 6. Thanks for watching. Catch you later.